So would you substitute the half for theta?
You
So
absolutely
would it
wouldn't.
be... You wouldn't, okay.
Solve. Theta equals, how do you get that?
Minus sign on both sides. Or could you divide by sign?
What is the opposite sign?
Inverse sign.
Yep.
So would it be theta equals a half inverse sine?
Yep. Well, inverse sine of a half.
Okay. And then can you work that out?
Yep. Calculate it.
Yeah. Which is 30.
And so theta equals 30. Is that full marks?
No. I don't think.
Do you remember how to get a second answer with sine?
Can you make it a cosine?
Sine theta is equal to sine 180 minus theta.
So can you do 180 minus 30?
Yep.
Which gives you 150. And then you got sine 50. Or is it just 150?
That's it. So you've got two answers. Theta is equal to 30 degrees and 150 degrees.
Yeah.
30 and 150. They used this stuff. Sine is always the same.
Yeah.
Okay. Let's see. How do we do part A?
Okay. I put into the calculator, it gave me minus 63.434.
And so x equals minus 63 point, let's say 4, was it?
Yeah.
Okay. And how do we find additional answers for tan?
You do 360 minus whatever it is.
That's for cos. Do you remember tan?
180.
Plus 180 this time.
Okay. So it'd be minus 63.4 plus 180.
Yep.
180. 116 point, let's say 616.6.
That's it. And how can we get another answer?
Is it 116.6 minus 180 or plus 180?
You can plus 180 again. Tan graph repeats every 180, which is the same as the original answer plus 360.
Okay. It is 296.6.
Well done. 296.6. So of our answers, which are in the range of 0 to 360?
The last two, so 116.6 and 296.6.
That's it. And so this is a perfectly valid solution, but it's outside of our range. So we leave it. Okay, how about this?
So can I put cos x equals 0.4 into the calculator?
Okay, you can do it.
which gives me answer of, still loading. I put equals 11 for x, and it gave me an answer of like 10 million, I think.
So the trick here is you do inverse cos of answer. Try that.
Okay. I got 66.4.
There we go. And so that one that you got is a valid answer. It's just, because it's going to repeat forever.
Yeah.
And so this is the principal solution, which is the one closest to 0.
Yeah.
B. So find additional solution between 0 and 360.
So could you do 360 minus 66.4?
Very good.
Which gives you 293.6.
Well done. Great. A bit weird. Okay. How would you do question D?
Okay.
No, that's weird. That's too weird. They're alright. Okay. How about this one?
So would you need to, can you put cos x and then square root 3 over 2 into the calculator?
Yeah.
Okay. $30.
Okay, so x equals 30 between 0 and 360.
Yeah, it is.
Okay, all the solutions between 0 and 30.
So 360 minus 30. Would that be right?
Yep.
Which gives you 330 degrees.
Identify the mistake the student made.
He did 180, which is sine, not cosine.
Yep. And write down the correct answer. You did.
Yeah.
The principal solution is correct, but second solution, whatever they're talking about. Nonsense. Okay. How about this one?
Okay. $23.56.
23.6.
And then you do 360 minus 23.6.
No.
Oh, wait, no, 180, sorry.
Yeah.
Which gives you 156.4.
Okay, I'm starting to get scared. You're too good with that calculator. Let's see. Yeah. Hang on. What am I looking at? 30. They have different answers, do they?
I think so.
Is this? It was minus 23.6.
Oh, because I wanted to make sure that it was right, so I did inverse sine and then it was minus 23.6, and then I clicked equals and it gave me a positive 23.6.
It shouldn't happen. Let me see.
I think that's what happened.
5 sine x. So that might be a limitation. That's good. I was getting scared. Shift solve. So follow, roll the dice. So I'm in radians. That's the problem. Degrees. Shift solve. So minus 23.6. And so this little thing I invented of shift cosine sine answer. It isn't. It's still negative.
Wait.
There's no way those two are the same.
Unless I did cos, I might have done cos. Wait.
Yeah, maybe you did cos. That would make sense.
Yeah.
So you have to do it in the one that it's in.
Yeah.
Okay, sine is minus 23.6. And so, how do we get more answers?
Wait, so would it be 180 minus 23.6?
Yeah.
Which gives you 203.6.
203.6. Okay. Is that all the solutions between 0 and 360?
No, could you do the double? Like,
What do you mean?
like 180 minus 23.6, and then that's 23.6 multiplied by 2.
To get any more solutions, you do your previous ones plus or minus 360. And whichever way you need them to be in the range.
Okay. So I did minus 23.6 plus 360, which gives you 336.4.
Okay. And
then would you do plus 360 to 203.6?
Yep.
Which gives you 563.6.
And so of our solutions, which are in the range?
336.4, 203.6, and that's all.
Yeah. 203.6. And so, yeah, you could keep adding 360 and it would keep giving you the same thing. But we have a limited range for a reason, so otherwise it'll go on forever. There we go. So 204,336. But you don't discard the one that's outside the range too early because we used that to get the one that's inside the range. I suppose we should, but let's just see. Before we get there. So what was this one? Okay, let's try question B.
Okay. So can we do inverse 2 cos?
So now you're doing it the normal way, are you? You would have to, well, what we could have done here is we could have started by, so we have 5 sine x equals minus 2. We could have started by dividing both sides by 5.
Okay.
And so then it would be sine x equals minus 2 over 5. And then we could do arc cos both sides. And we would get x equals arc cos minus 2 over 5, which is that minus 23.6.
Yeah.
And you chose to put it on the calculator, so it's whichever way you want to do it. B.
Okay. So would theta be x then?
Yeah, it's like x, yeah.
Okay. $135.
Theta equals 135.
Yeah.
Okay, between 0 and 360.
Do 360 minus 135,
Okay.
which gives you 225.
Okay, let me just check. Negative root 2 equals this. Divide by 2 equals this. Shift cos 135. Yeah, great. And let's try question G.
Okay. I got minus 74.7.
Okay.
And then would you add 360 to it?
Second answer for 10.
So would you add 180?
Yep.
Okay. Which gives you 105.3.
And now you can get third and fourth answers and stuff.
The what? Third and the fourth?
Yeah, or any additional solutions.
Could you add 180 to 105.3?
Yeah, and that's the same as adding 360 to the original one.
Yeah.
It's just that it would skip the second answer.
Yeah, and that gives you 285.3.
Yeah. And if you just follow that process, you'll always get all your solutions.
Yeah.
That's theta equals. Great. Okay, so we did one with sine, we did one with cos, we did one with tan. And you're using shift tan for these, are you? Or shift cos?
Yeah.
Okay. These are a bit weirder, but I'm gonna. The only thing here that's different is they wanted it between minus 180 and plus 180. So maybe this negative answer would have been valid, and maybe you would do 360. You would subtract 360 from 105 or something.
Yeah.
Who knows? Okay, how do we do this weird one?
Okay. Is cos squared x the same as cos x squared?
Yeah. Cos x all squared.
Okay.
It's just to show that it's not just the x that's squared, it's the whole thing.
Okay. I got 74.7.
For x?
Yeah, for x.
Okay. We want solutions in this range. How do we do this?
Would you use the word 360 still because it's cos?
Yep.
So could you minus 360 from it?
Well, let's just do it the normal way, and then we'll figure it out.
Okay. So we add 360 to it.
That's not the normal way.
Oh, it's 180 because it says 180, right?
That's not the normal way for cos. How did we do the cos one for part B? How did we get second
Oh, you
answer?
did 360 minus the number,
Yeah.
which gives you 285.3.
So 285.3. So now let's try to get extra answers in the range.
And then could you do 285 minus 360? No, 360 minus 285 again.
You would get 74.7.
Could you do the original answer taken away from double 360?
Not double. It's just, so these are our two answers. And so these ones, plus or minus 360. So you can add 360, you can subtract 360, and you want it to get an answer in this range. So if you did 285.3 plus 360, that's definitely going to be outside the range.
Okay.
I imagine the same for 74.7. So how can we get answers in the range?
Could you minus 360?
Yeah, try minus and 360.
Okay. Which is minus 285.3 for the first one.
Yeah.
The next one is minus 74.7.
Yeah. And so cos has that kind of symmetrical property to it, but it's the only one that does. And so this method works for all three of them.
Yeah.
And so which are the solutions in the range?
74.7 minus 74.7.
Yeah. Great. And I'll just write it the short way. Great. Yeah. So, yeah, any questions about that one?
No.
Yeah, so get the two main answers, and then, what's this? Plus or hold on. Was your original answer wrong? Did you do squared? Oh, I know. Okay, finally. Hang on. That doesn't make sense. Are you sure about your original? How did you get this one? You put in the calculator?
I did brackets cos x close brackets squared equals 3/4. Shift solve, put a random number in, and then I did cos answer.
No, why did you do? It's shift cos.
Yeah, I did shift cos, inverse cos answer.
Okay, shift cos.
But this time I got 30 for some reason.
I think you pressed cos twice or something.
Yeah, probably.
Something went wrong. Okay, so it should have been 30 and 150. However, there is a limitation here. So if we were to do this normal way, square root both sides, what do you get?
Cos x equals square root 3/4.
Wrong, believe it or not. Cos x equals square root of 3/4. It's two of them.
Okay.
Because the negative root 3/4 squared. That's outside. Hang on. Yeah. No. Yep. Squared also gives you 3/4.
Yeah.
And so you have to do the two separately. And it will work actually. Let me see. So cos x equals root 3/4. So you could do that one in the calculator.
Yeah.
Or cos x equals negative root 3/4 and do the two separately. But let me just... It doesn't save those things. Bracket cos x. So one of the limitations of the solver, and actually it's not a limitation of the graphical one. Graphical one gets them all, I think. Alpha equals 3/4. Shift solve. So when we choose that one, we get 30. But what if I was to choose shift solve? What if I was to choose minus 999? Just want to see what happens here. Okay. So yeah, this is definitely, so then you do shift cos answer, and it gives the principal. Yeah, so that's a limitation. It's given us just the positive one, and it's because it's giving us just one solution. And so you have to split it in two because it's that squared thing. Okay, let's try this one.
Yeah. I got 71.6.
Okay.
I did inverse tan answer. And I got 71.6 for theta.
Okay. Any more solutions?
Okay. Would you do 71.6 minus 360?
This is for tan, second answer.
Would be 180.
Yeah, 180.
Minus 71.6.
No, that's for sine.
Plus.
Yep.
71.6 plus 180. Which gives you 251.6.
51.6. So they're both between 0 and 360. However, you learned nothing from our previous question. If you were to solve this manually, what would you get?
So you do square root both sides.
Yep.
Which gives you tan theta equals plus or minus square root of 9.
Yes, and so that's plus or minus 3.
Yeah.
And so I think you got the plus ones.
Okay, so then you do tan x equals minus 3.
Yeah.
Minus 71.6.
Aha. Okay. Okay, yeah, go on. And so...
Okay. And then you'd add 180 to it.
Yeah, what do you get?
108.4.
Okay. Can we get additional solutions?
Could you add another 180 to it?
Well done.
So 108 plus 180 is 288.4.
Well done. And if you added another 180, it would be it would be outside the range.
Yeah.
What was that one, sorry?
288.4.
0.4. There we go. And so it's squared, so you've got plus or minus.
Yeah.
So you get double the number of solutions. 71.6, 108.4. Great, great, great. Remember that one? Is it time for this? It is. All right. How do we do this thing?
Okay. Would that not work in the calculator?
You can try.
Okay. It gave me 60.
So theta is 60.
But how can you make sure it's 60? Because you can't do. You got sine and cos. So do
Yeah.
you do inverse for both?
This is crazy. Let's try it.
Okay. 60. So inverse sine 60 is 60, and then both of them are 60 if you do the inverses.
Yeah. And so, how do we get second answer though?
Would you do for both? So 180 minus 60.
Yeah, try it.
Which gives you 120.
Okay. And then the other one?
360 minus 60, which is 300.
Let's see. And so those are our solutions, are they?
Aren't there more solutions?
I'm just thinking between 0 and 360. If we add 360 to any of these, it'll be outside the range. Same with
Yeah.
subtract. 60 or 240. Why did that? Okay, so this method just didn't work. Maybe it might be that simple. And let's just check. And so, sine of 60. I think 60 will work.
Yeah.
And then cos of 60 should be a half. Yeah. Cos of 60 would be a half, which would be times root 3 would be the same thing.
Yeah.
So now let's try sine 120. Okay. What is cos? Oh, I see what's happening here. Cos 120. It's going to be negative. Yes. So that's the difference. Okay. I shall help you.
Okay.
We didn't do too badly. So the calculator gets limited after a while. Divide both sides by cos. What do you get? Cos theta.
3. So do you get? So on the right the cos's cancel out, so it's just square root 3.
Yep. And on the left, do you know
On the
what
left,
sine theta divided by cos theta is?
so is it tan theta?
Well done.
And then would you need to? Can you just put that into the calculator, or do you have to make tan on the right side?
Any way you like. Should work.
Okay. I got x is 60.
So theta is 60. And
Yeah.
now it was tan. So additional answer.
Is that plus 180?
Yeah.
240.
And so theta equals 60 or 240.
Yeah.
60, 240. Great. So if you have a mixture of sine and cos, divide by cos to get tan. Let's see.
Yeah.
Let's try very last one.
Okay. So would you need to divide by anything for this?
Yep.
Does it matter which one you divide by if you want to get rid of sine or cos?
Matters greatly. What? What?
Oh, it's 360, so you want to get rid of sine, don't you?
So, how would you do that?
Divide by sine theta on both sides. Divide everything.
Okay. What is cos theta divided by sine theta?
Tan theta.
That's sine divided by cos. Do you know what cos divided by sine is?
Is it inverse tan?
It's something wacky. Let's not even.
Oh.
Let's just divide by. What would you divide by then?
Cos then.
Yeah. Always cos.
Okay. So then you'd get square root 5 tan theta plus square root 2 equals 0 over square root cos. Not square root cos, just over cos.
What is 0 divided by cos theta?
0?
Yep.
And then would you minus square root 2 on both sides?
Yep.
Which would give you square root 5 tan theta equals minus square root 2.
Yep.
And then could you put that into the calculator?
Yep.
I got minus 32.3.
Okay. 32.3.
Yeah, I think so. Let me double check. Yeah, minus 32.3.
Okay. And so.
You'd add 180.
Yeah.
Which is 147.7.
Is that it?
And then could you add 180 again?
Yeah.
Which gives you 327.7.
Well done. Great. Okay. So if you have a mixture of sine and cos, divide by cos. I think you're good there.
Yeah.
All right. How about this one?
Okay. So would you divide by cos on both sides?
Yep.
Which gives you 2 equals 3 tan x. And then you could just put that into the calculator.
What would tan x be equal to?
Just tan x.
Yeah.
We don't know what x is though.
Like rearrange.
Oh. Can you just minus or divide by x on both sides?
We're trying to get rid of not x, trying to get rid of the 3.
Oh. So it'd just be minus 3 on both sides. So minus 3 equals tan x.
No. 2 equals 3 times tan x.
Oh. It'd be minus 1 equals tan x.
No. This isn't 3 plus tan x. This is times 3.
So you divide by 3.
Yep.
So 2 divided by 6, 2 over 3.
That's it. Identify the mistake made by student A.
He made tan x 3 over 2, not 2 over 3.
Yes. And then student B. Any idea what that's about?
Okay, let's see. So could you still divide by... Could you divide by cos squared x? Would that still work?
Well, what did he do? He squared both sides, I think, and then he used trig identities. So sine squared x is equal to 1 minus cos squared x. Cos squared x is equal to 1 minus sine squared x. So that's what he did. At the end, he had like plus or minus this, plus or minus this. I think you're not supposed to keep all the positives and negatives.
Yeah.
You have to actually say what like quadrant it's in. I'm not even going to mess around with that. You're okay for getting the answers.
Yeah.
Let's see. Given that 3 sine hence or otherwise. Okay, what would be part A?
Okay. Three tan theta equals 5.
Okay.
And then could you put that into the calculator?
They said find the value of not theta but tan theta.
Okay, so you want to make... Oh, you want to get rid of the 3. So divide by 3 on both sides.
Mm-hmm. Yep, what do you get?
You get 5 over 3, so tan theta equals 5 over 3.
Yeah, and so that's the answer for part A. Tan theta is equal to 5 over 3. And then part B, you'd solve not for tan theta, but for theta. Yeah. So just watch out for that. 5 over 3. Some student made some mistake. Oh, wow. I don't know. He was mixing tan x and sine x. We'll get there. Line 3. Oh, I see. Let's see. Whoops. Okay. Any idea how we do this one?
Okay. 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 So would you divide by cos squared x?
No. What's the main difference between... So, because that would get you like tan squared. They don't have tan squared though.
Okay.
Do you want to show that can be written as cos squared?
Yeah.
Any idea how we go about that?
Would you need to use trig identities? Okay. So it would be written out as 1 minus sine squared x.
Yeah. But we want to keep cos squared x. What is sine squared x the same as?
1 minus cos squared x.
Squared x. Okay. And so use that.
So it'd be 4 cos squared x minus 3 brackets 1 minus cos squared x equals 1. And then would you multiply out the bracket?
Yep.
Okay. So would you multiply minus 3 by minus cos squared?
Multiply by minus 1 as well. Multiply by 1 as well.
So it would be 4 cos squared x minus 3. And then would it just be cos squared? Or 3 cos squared?
Yeah, plus or minus.
Plus.
Well done.
And then can you add 3x to 3 to both sides?
Yeah.
Which gives you 4. And then could you just add them together?
Yep.
So it'd be 7 cos squared x equals 4.
Which is what we had to do.
Yeah.
Okay, solve.
Okay. Don't we already have the answer to the first part though? The second part, like half of it. We have 7 cos squared x equals 4.
Solve for x.
Okay.
Sorry, you're correct. Yeah. So, go on. What do you mean by that? Or how would you do this one?
So we can use 7 cos squared x equals 4.
Yeah. It's the same question, just written a different way. And so the solutions for this one are the same as the solutions for this one. Yeah.
Yeah. And then would that work if you put it into the cat? No, it wouldn't. Would you square root both sides?
I would divide by 7 first.
Okay. So it'd be 7 cos. No, it'd be cos squared x equals 4 over 7. And then it would become cos x equals plus or minus square root 4 over 7.
Yeah.
And then you do the positive one first.
Yeah, go on, try that.
Okay. So it'd be cos x equals square root of 4 over 7. So 40.9.
Okay.
Then should I work out the other ones or work out the other values for 40.9 first?
Let's do the 40.9 one.
Okay. And then would you do 360 minus 40.9?
Yeah.
Which gives you 319.1.
Yep.
Okay. And then you do cos x equals minus square root of 4 over 7. Wait, no, 7 over 4.
Oh, sorry, I wrote it wrong. 4 over 7.
Oh, it's 4 over 7. I got 139.1. And then you'd minus it from 360, which gives you 220.9.
0.9. Let's take a look. 240, 139, 220, 319. Great. And so, yeah, you just have to use trig identity to swap. And then this harder equation to solve can be written as this easier equation to solve. And so we solve that instead. Watch out for the plus or minus.
Yeah.
Any questions for that? Okay, let's see. Any idea how you'd do part A for this one?
Okay.
Or how you'd start it?
Would you need to use trig identities again?
Nope. How would you solve x plus 2, x minus 3 equals 0?
You just expand the brackets.
No. Two numbers multiplied to make 0.
Oh.
Can you think of any two numbers that multiply to make 0?
Let's just do 1 and 0, I guess.
Yep. Is it possible for two numbers to multiply and make 0 where one of those numbers is not 0?
Yeah.
What would they be?
It's possible. You could just do any number like 3 and 0.
So one of them has to be 0. Like you can't.
So 3 and 0, right?
Yeah. So like one of the numbers has to be 0. You can't have like 2 times minus a half or something and get 0. So what that shows us is either the first one is 0.
Yeah.
Or the second one is 0.
Yeah.
And then you'd solve them separately.
Yeah.
So for that one, x equals minus 2. For this one,
X equals 3.
Yeah. Okay. Apply that to this up here.
Okay. So you do 2 plus tan theta equals 0.
Mm-hmm.
And then 4 sine theta minus 1 equals any other number.
No.
Would it also be 0?
Yeah. Either this equals 0 or this equals 0.
Okay.
And then you just solve the two separately. They're quite easy to solve, but that's how you deal with the brackets.
Yeah.
The other one we didn't do, simple trig equations. Yeah, we'll call it a day. And so what do you give yourself there?
All in between a tick and a half.
So I think trig is the hardest thing.
Yeah.
Hang on. Huh? Those were simple trig equations. Next time it's more difficult trig equations.
Yeah.
How was that for you, Adam?
That was good.
And so any questions from me in general?
No.
All right. Well, well done, Adam. You did great.
Thank you.
And look forward to talking again after the weekend.
You too.
All right. Take care. Goodbye.
Bye.
Bye.